Okay, on to part 2, which is covering chapter 10. I think they took pretty easy on you guys here because there are 7 questions from chapter 8, 7 questions from chapter 11, but only 6 from chapter 10. Okay, sorry. Says, show... Oh man, it says a lot here. But one thing I want to highlight is that they're saying intersection. So remember, intersection is only where they overlap. Okay? Now, it says DA, and then it has an arrow above it pointing from the D to the A, which means it keeps going past A, on and on forever and ever that way. Okay? And then the other line segment is from A, B, and it also has an arrow, which means it keeps going on and on and on and on forever. Okay? So, remembering that this is intersection, only where they overlap should just be from this point here to this point here, right? I don't want any arrows. I don't want to extend in either direction. I want to start at A and end at D, and that's it. Okay, so you know you can't use B or C because those both have arrows. And for option A, it would only cover to this point here, which isn't long enough. That would exclude this little segment between C and D, which I don't want to do. So the answer is D, A to D line segment, starting at the point A, covering everything to the point D, and that's it. That's the only place where it overlaps. Okay? The other option, of course, would be if they talked about the union. All right, remember, union is everybody in the bucket. All right, if this had been a union instead of the intersection, okay, it would have said that I want to include everything from either line, everything you see up here needs to be in my answer. So remember, it went on forever and ever to the left. The other segment went on forever and ever to the right. So the answer, if it had been a union, would have been C. Extending with the arrows past A and with the arrow past D, that would actually be the union. But this is intersection, so the answer is D. Okay, D. Oh, Jesus Christ. Oh, okay. Well, I don't think it was recording my voice that whole time. I'm not really sure. Now, number 9. So this one is actually a Pythagorean theorem problem. So they talk about a rectangular garden bed measuring 16 feet by 12 feet. And then they talk about having a water faucet located at one corner of the garden bed and a hose connected to that water faucet. And the hose has to be long enough to reach the opposite corner of the garden bed when it is stretched straight. Okay? Find the required length of hose. Alright, so I drew a diagram because that's always helpful, right? So I made the rectangle, labeled it 12 by 16 feet. I should have written that here, but was getting tired. And I noted on the second dot that you're given A and B. You're given 12 and 16. Remember, C, the hypotenuse, is always the longest side, the diagonal. Huge long side, okay? So we don't have that, all right? So what we're looking for here instead is, I'm sorry, we don't have that, so that's what we're looking for. Haha! So we have A and B. So I wrote Pythagorean theorem here, A squared plus B squared equals C squared. That's the third dot. And then I filled in our A and B. 12 squared plus 16 squared equals C squared. I left it as C squared because we don't know what it is yet, right? All right, now, I couldn't find the symbol for square root on PowerPoint because I don't know why I can't find it. So I simply wrote the square root of 400. 400 is 12 squared plus 16 squared. So 144 plus, I don't remember what 16 squared is, 256 maybe? That sounds about right. I'm not really sure. But if you were to add those two squareds together, you get 400. So you take the square root of both sides, square root of c squared is c, square root of 12 squared plus 16 squared, and you would get 20. Okay? 20 would be your c, which would be your length, your hypotenuse, the green line, the hose stretching across your rectangular garden bed. Okay? Now, half of this problem is going to be figuring that out, and the other half of the points from this problem are going to be the units. This didn't require any area or volume or anything like that, so the units are still straight feet. Okay? No squaring or anything like that, and then we didn't have to make any conversions, so you can leave your units in feet. No need to make it into yards or inches or anything weird like that. Okay? All right. Next slide. All right, number 10. Number 10 says a school playground is in the shape of a rectangle, 800 feet long, 100 feet wide. If your fencing costs $14 per yard, what will it cost to place a fence around the playground? Okay, so what I noticed here is the school playground is 800 feet long, but the fencing costs $14 per yard. Something's wrong because my measurement is in feet, but my cost is in yards. So normally we adjust that in the beginning. So I went ahead and I made my rectangle. I labeled it 100 feet and 800 feet, and then I converted those both into yards. Okay? All right, so like I said, this is a perimeter problem. We want to find the distance around the outside, and then we want to pay per distance around the outside. So it's perimeter, basically. All right, now, perimeter for a rectangle is equal to 2 lengths plus 2 widths. Okay, so I went ahead and left these in the converted format of 100 divided by 3 and 800 divided by 3 because they balance each other out and basically make the amount like 599.9 repeating. Like, it's ridiculous. Or I think if you do it all together in one step, it does come out straight 600. I don't know. But the point being, you kind of want to round to the nearest yard, which was 600 for me. And then, now that we know how many yards, we just multiply by how much it would cost per yard. So 600 times 14 is 8,400. Now, I know some of you like to wait and make your conversion from feet to yards at the end. That's fine. Okay? Just got to make sure you're dividing properly. So, what was I going to say? I don't know. 2 times 800 should be 1,600, plus 2 times 100 is 200. So 1,600 plus 200 is 1,800. Divide that by 3, and you would get 600. Okay, so either way, if you want to, this one doesn't have a bunch of multiplication, so you can do it at the end if you want. It won't be too confusing. Just, I guess the point being, remember that they like to do this trick where they mix up the units. Okay, they give you one, but they want the other, and so just be aware and watch your units. Okay, but the answer here should be $8,400 to fence in the entire school playground. Okay? All right. Okay, so the total area would be taking the triangle and adding the area of the rectangle to it, right? So first, let's find the triangle area, which is 1/2 times 30. Remember, the base is the entire bottom. And then I left it as 22 minus 14 in case some people weren't sure where I was getting that 8 from. And when I did it in my calculator, I got 120. And then for the area of the rectangle, it's simply 30 times 14, length times width. And that gave me 420. So the total area of this whole figure would be adding the triangle top plus the rectangle bottom. 120 plus 420 is 540. Okay, now remember that's only half the answer. So since we did multiplication, length times width and base times height, we did meters times meters, and meters times meters makes meters squared. So anytime you have area, remember area problems, your units should be squared. Perimeter, plane units, area, squared units, volume, cube units, okay? And remember, these are unit exams, so if you don't pick the right bubble, you're only going to get half the problem right just because you selected the wrong units. Okay, so I would hate for that to happen. So make sure you select the proper units. Wow, I keep doing that. And so I got 288, and then I wrote my pi with it. Okay, units, again, this is volume. Volume means my units have to be cubed. Cube, okay, cubic. And you know, because your R is cubed, so your radius is cubed, that means your units have to be cubed, right? And then, so like I said, 288 times pi in your calculator, if it doesn't give you the approximation, I think you can hit your S to D button and get the approximation. Should be rounded to the nearest whole number, so mine spit out 904.77, and I rounded that to 905, regular rounding rules, right? Round the 4, you look to the right, see a 7, bump it up, right? Because 7's bigger than 5. Okay, but like I said, perimeter, plane units, area, square units, volume, cube units, okay? And surprisingly, like I said, this is way too easy. That's it. That's it for chapter 10. I think you guys will be okay. Again, like I said, you really need to make sure you have your calculator, and you really need to make sure you ask for the formula book, because the volume formula should be in there for a sphere, and your area formula should be in there, because there's so many of them. Because it could ask you for the volume of a can, a circular cylinder. It could ask you for the volume of a swimming pool, you know, because remember, these questions, it's just the type of question that they're going to ask. So you can expect a volume question, an area question where you have to combine different shapes, right? Another area one with different shapes is like the ice cream cone with the hemisphere and the cone shape you have to add together. What else is an area one? I can't think of another one. But anyway, a combination area. Then they had this perimeter problem with the switching of the units. They had a Pythagorean theorem problem, which I think you can pretty much expect. And then kind of a gimme with the rays and the line segments. Just be careful about the arrows and whether you're talking about union or intersection. But yeah, I think chapter 10, that should be a breeze. You should get through this part pretty easily without a lot of stress. Okay, so that's it for this portion, and then the next video will cover chapter 11. Okay.